Okay, so hey guys, and welcome to Half Master Gaming. I know this isn't a gaming video, but I do a lot of videos, and I basically just do whatever I want on this channel, so yeah, it's not a gaming video, but it's pretty interesting, so I suggest you watch it. So, if you guys know the iPhone has a passcode on it, and the two basic passcodes were there was the typing one, the one with an actual words. There was the 6-digit one, there's the 4-digit one, and now they have the new any length numbers only one. And so I'm going to be talking to you about how many possible iPhone password combinations are there and how long would it take to figure out a password, as shown over here. So I'm going to do it for 4 and 6-digit because if you looked at the typed one or the infinite digit number passcode, then all of those would take infinite time to figure out because it's the infinite number of possibilities. And like if they're not limited on length, then they would take infinite time to figure it out, and there'd be infinite possibilities. So I can't really do those for you. And today I'm going to be using a program called Scratch in my video. And Scratch is just basically a starter programming language which you can start with. And it's just like an actual programming language, except for you use these blocks like this. And you basically just change the variables in the blocks to give you whatever you want like this. And there's no errors in Scratch. It's really easy to learn. It's a great way to start learning, so I suggest you use it, but it can also be used for tons of different things. So just give it a try. It's scratch.mit.edu. So I'm going to be talking about the 4-digit one, and let's calculate how many different possible iPhone password combinations are there. So if you think about it, the iPhone has it has 0 through 9 on the numbers on the number keypad, and so that's 10 different numbers that it can have. So I have right here a decagon, and it has 10 sides: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so this thing has 10 sides. There's 2 of them. I can move them around like this. And so each side represents a number in the passcode. So I'm going to start off with just a really basic visual one to show you how. So this would be this right here is for 2 digits. This would be a 2-digit password. And this is just to show you my logic. So if you think about it, this is the first digit, this is the second digit. So say this is 1, so the first digit's 1. Let me write that up quickly, really, right there. The first digit is 1. Put that right over there. Make it a little bit bigger. So let's say the first one is 1. So each side on this is side 1, side 2, side 3, side 4, side 5, side 6, side 7, side 8, side 9, and side 0. And so basically what we have right now is, if we look at decagon 1, this is 1, this is staying 1. And so we're testing 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's all 10 different combinations, and then going back to 0. So basically if this is 1, then this can be 10 different things. So if you think about it, all you have to do is, since this can be 10 for every one of these, then you just multiply 10 times 10, and then there's 100 different possible combinations if you have a 2-digit password. Because then you could take this one, you could rotate it this way, like that. So this one's now 2, like that. And now that this one's 2, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different combinations for 2. So that's 20, and we've only gone through 2. And there's 10 of them, so the answer is there's 100 possible combinations for a 2-digit. So basically, if you think about that, there's 10 digits, and you have a 2-digit one, so it's basically just 10 times 10, which is 100. And so if you think ahead, what would 10 times 3 be? So if you get another decagon, so now we have a third decagon. So now we do everything here. This one's all the way around. Let's say this one's 10 now. And so this one now has 100 possible combinations, these two combined. Then this one over here is like another one. And so now, so basically now this one, here, let's build another one, and then make it 1, like this. Let's make it bigger. So now this one's 1, and this one can also be 1. And so now you have 10 different possibilities here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And then here, you also have to do 10 different possibilities. So you have 1 through 10 on this one also. So I'm going to change this to 10 now. And so now you have that. But now you do that over and over again until you get to 10. And then you reset this one to you reset this one to 1 or 0. Sorry, it would be 0. Both these would be 0. And so now, once you've gone all the way through with this middle one, the third one is going to change by 1. So now this is... Oh, not that. So now this one right here is 1. So now you go all the way around with this one again, and this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now there's 200 different possible combinations. So the answer to that would be 10 times 10, which is 100, times 10, which is 1,000. And so you have 1,000 different combinations if you have a 3-digit passcode. And if we were to do that mathematically, it'd basically just be 10 squared. Or sorry, not 10 squared. 10 to the power of 3. So, it basically 10 times 10 times 10, which is 10 to the power of 3. Which is pretty easy because now, I'm pretty sure you can guess, a 4-digit passcode would be 10 to the power of 4. Wait, sorry. No, this is 10 to the power of 2. Yeah. Wait. Sorry, yeah, 10 to the power of 2 is 10 times 10. So 10 to the power of 3 is 10 times 10 times 10. So yeah, this would be a 4-digit passcode. So if we had another decagon here, boom, this would be 10 to the power of 1, 2, 3, 4. So 10, here, let me write that. 10 to, let me put that up there. I'll make this 1 to the power of 4. 10 to the power of 4. And then I'll just draw little lines going to all of those. So 1, 2, 3, 4. To make all these lines bigger. 5, and make them red. Oops. Make them red. There we go. So now we have, drag this up. So 4 goes to all 4 of those, like that. Yeah. Anyway, so 10 to the power 4, because there's 4 different digits, or, yeah, 1, 2, 3, 4 different digits that you can enter in. 4 different possible digits. So it'll be 10 to the power 4. And so 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So now we've answered our questions up here. If you have a 4-digit passcode, how many possible iPhone password combinations are there? 10,000. Which is a lot of combinations, because that number can get really big really quick, especially with a 6-digit. So, now let's move on to the, how to figure out how long it would take. So this one's going to be a little bit harder. It might require a little bit of code. But now if we think about it, let me delete some of these things because, yeah, I like to be clean. Start with our main 2. Okay. So now if you think about it, how long would it take? So we have, let's write that up there, 10,000. Whoops, okay. Sorry, writing in invisible ink, which is not fun because you guys can't see that. Okay, there. 10,000 different combinations. And so we want to find out how long it'd take to figure out a password. So if you think about it, the iPhone, or actually let's think about it. The first, I'm bad at spelling, time you get a passcode lock, the iPhone locks you out for 1 minute. And then the only thing, this is, the way it works is the second time, so let's just duplicate that. So if you say the second time you get a password lock, second time you get a passcode lock, the iPhone locks you out for 5 minutes. And that's the only non-mathematical thing. That's just was set by them. But for the next one and so on, let's put that there too. so you guys can see. Let's make this a little bit bigger so you guys can see. Okay, so now for the third time, now it's pretty mathematical. At least this is not how my phone works. I'm not sure how other phones work. Of course, I have an old phone, so yeah. Well, I do have an iPhone, but still. So now it locks you out 10 minutes and just doubles the number from then on. So basically, whatever it is, it just adds it to itself and doubles it from then on. etc. So, normal calculators have a hard time calculating this. That's why I'm doing it in Scratch instead of just using a calculator. So, if we think about it, there's 10,000 different possibilities. And we're going to assume that whoever's trying to figure out your password, they only get it right on their very last try. So we're going to find out how long would it take them to figure out your password if you had a 4-digit iPhone password and they only got it on their very last try. So, so if we think about it, we go here, and I'm going to just do a little bit of coding. So let's find out. So let's make a variable called our answer. And if you guys know how to code, you know of the booleans and the variables and all that. So this is kind of like that. This is Scratch's version of a variable, and it's a lot simpler. It's just literally a variable, and you can double click on it to change it like that. Because on the slider it only goes up to 100, but you can like make it disappear. But you can change it as much as you want. So basically what we're going to do is we want to repeat it, and since there's 10,000 different combinations, we want to try 10,000 times. That's a lot of repeats. So basically what we're going to do is, let's show the variable, our answer. So this one right here is our answer. And so what we're going to do is we're going to start out, set our answer to 5, because the one digit is different. So actually this should be 99,000, or 9,999. So almost 10,000 because we're skipping 1. So now if we think about it, we set our answer to 5. So because we're starting from 5 minutes instead of 1 minute, because 1 minute to 5 is kind of not good. So we're repeating it 999,000 times, or not 900, yeah, sorry, 9,000 times, 9,999 times. And so we're just going to say repeat 9999, and then we're going to say we're going to set, let's see, set adder to our answer plus our answer. Actually, we can just say set our answer to our answer plus our answer. So like that. And then when we run this, frick. I hate this. I didn't think you'd do this, but that's what the Google calculator does too. It just literally says infinity because it's such a massive number. So let's try that 999. Yeah, that's a massive number. No calculator is big enough to show this. Why? Why? Why do you do this to us? So yeah. So I think this is the best answer we're gonna get. How long it takes to figure out a password? 4-digit. According, I'm so bad at spelling. According to Google calculator and Scratch. Because yes, I did test that on Google calculator earlier. The number is so big it would take in infinity. But if we think about it, let's say we did a 2-digit. 2 digits. Then we calculated that here, so 2-digit is 100 times, so we're going to do 99 times. And the answer is a lot. So let's just Yeah, that's pretty big. There's actually no way to... Oh, yeah, there is. If I click make a list, and then I do whatever, 6FG, then add our answer to list. Add our answer. Break. There we go. If we add our answer to that, now we can make this bigger and copy it. So even if you had a 2-digit passcode, and here, let's say minutes. So even if you had a 2-digit password, and assuming the person only got it right on their very last try, it would take them that long with trying to find it on an iPhone just to figure out your password if they only got it right on the last try. Which is a lot of minutes. But let's go over here to this and then say that, and then times. If we said that, and then we said oh, I just forgot my train of thought. Seriously. Oh yeah, if we did hours to minutes, so actually let's do minutes to days. Divide the value by, sorry, 1 minute equals, yeah. So now let's put our number here, divided by 140. It's still massive. Oh my gosh. Okay. Say days to years. 360. Of course, I'm stupid. So let's do that. Divide it by 365. 365. Boom. Stop. Okay. Years to centuries. Divide the time value by 100. Okay. Actually, why am I looking this up? Oh wait, whoops. Forgot to copy that. Seriously, did I copy that number? Okay, copy that, paste that in, divided by 100. It's still massive. So yeah, it'd take you 6.0295403E plus 22 centuries just to figure out, assuming you got it right on your last try. CNT. Assuming you got it right on your last try, it'd take you 6.0295405E plus 22 centuries just to get a 2-digit password correct on an iPhone, which is insanely large amount. But if you think about it, 2-digit password is a lot more secure than 1-digit, because if you think about it, this would be a lot easier if it was a 1-digit password. If you did that, it's literally just, it would take you 2,560 days. So, assuming if it was a 1-digit password and you were on the Apple lock system and it locked you out on your first try every time you did it, then it'd take you 2,560 days. Let's do 2,560 divided by 365, and it'd take you 7 years to figure out a 1-digit password if you got it right on the first try. Or if you got it right on the last try, sorry. And that is insane. Here, let's say 1-digit, literally 7 years. And that is absolutely insane. Like, how is it so secure? Oh my gosh. But that is the truth, and that's how long it would take, and I really don't want to do this all over again, so I will let you guys figure out for the 6-digit passcode. Hopefully one of you has a calculator that can actually fit a number that's big enough and doesn't just say infinity. So I'll let you guys figure out the 6-digit one, and how long it would take to figure out the password, and how many possible... Actually, I'll do the combinations for you. Well, if you don't want me to do... I'm going to do the combinations, but not the, how long would it take. So, right now, pause the video, and, and go down into the comments and paste your answer for or try to calculate how many possible combinations there would be, and paste your answer in the comments, and I'll look over the answers. And please don't copy somebody else's answer, because that's just cheating. Try to calculate it for yourself, you know, brain games. But now I'm going to do it, so just pause the video. I'll give you 3 seconds. Okay, so I hope you paused the video and done it, but now I'm going to calculate it for you. So, how many possible iPhone password combinations are there? So, it'll literally just be, it would literally just be 10 to the power of 4. And 10 to the power of 4 is for a 4-digit, so if you try to calculate 6-digit, it'd be 10 to the power of 6. And so if you did that here, that's 10 times 10 times 10 times 10 times 10 times 10. So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000, times 10 is 1,000,000. So there is 1,000,000, 1,000,000, 1,000,000 different password combinations for a 6-digit combination. And if you try to do that in Scratch, it'll also say infinity, so I'll let you guys figure that out in the comments. If you do have a calculator that's big enough and won't just say infinity, please just tell me in the comments, and I would like to know that. So, yeah, I don't like calculators that just say infinity. I want the actual number. But, so that's all I have for you today. This is all the, here, let me make this full screen. This is all the information we have, so if you want to copy this down somewhere, it'll also be in the comments down below. Don't forget to subscribe and like this video. I hope it was informational for you to learn this. I probably went into a lot more detail than most people, but I'm sure there's a lot of people that have done this before me. But just thank you for watching. Don't forget to subscribe to my channel. My channel is a gaming channel, but I also do other things like this video. But thanks for watching. Don't forget to subscribe. And my brother's channel is Crisk World, so he made a video early today also. So if you'd like to go subscribe to him, he's in my channel. Go look for him. And thanks for watching. Goodbye.